In an experiment, a proton accelerates from rest between parallel charged plates. The spacing of the plates is 12 cm and the proton is initially positioned at an equal distance from both the plates, as shown. Ignore the effect of gravity. So part A is the electrical potential energy of the proton is recorded in the following graph for the first 5 cm of its motion. On the graph, sketch the corresponding kinetic energy of the proton over the same distance. So at any point of time, the total energy, maybe if I can write total energy, which is equal to the sum of potential energy and the kinetic energy, that has to be constant. We are neither providing energy to the system nor we are taking energy out of the system. So therefore, at all point of the graph, this condition has to be satisfied. So if we look at the graph at distance 0, the energy is given as, maybe if I can do the numbering, 1, 2, 3 and 4. So 4 units, whatever be the unit of the energy, 4 units of energy are there at position 0, at 0 distance. So, and at this point of time, we have the, at this point, we have velocity equal to 0. Therefore, kinetic energy equal to 0, and therefore this complete 4 units represents the potential energy at this point, and kinetic energy at this point is 0. Yeah, so the total is 0 plus 4 units of total energy. So we have got one coordinate over here at origin O. This coordinate is at 0 position, the kinetic energy is 0. And in terms of the motion of the object, so this is since it is positively charged and it is negatively charged, so the proton will definitely move in this direction at with an initial velocity v of 0, which is shown here at origin O. And to complete the graph for the kinetic energy, we need one more point on the graph, and therefore at this maybe distance of 5 cm, the potential energy is already given to be 1 unit, and given that the total has to be 4, so the kinetic energy point will be somewhere over here. So if I can write point B over here, it will be on the x-axis distance 5, and on the y-axis the unit of energy with 3 units. So join the 2 points O and B, that should give the graph for the kinetic energy. So my graph may not be as good, but this is how the graph will look like. You will use a scale or ruler to draw the line, but I have drawn it manually, so it is roughly the same. So that completes answer to part A. The experiment is repeated using an electron in the place of the proton. Explain how the motion of the electron would differ from that of the proton. So basically, when we have to describe the motion, there are various parameters we have to describe. We have to describe about the force, which includes its magnitude and direction, and then the acceleration, and then of course velocity, and then the time taken to reach to the other plate. Let's prepare a table. Say for example, we use this for proton and this one for electron. So to be able to differentiate in their nature of the motion, so first let's analyze the magnitude of the force. So the magnitude of the force is given as Q into E. Yeah, so this will be the charge on the proton, QP, times the electric field intensity, and in this case it will be charge on the electron times the electric field intensity. So since the electric field intensity is the same for both proton and electron, and the charges on proton are the same as the charge on the electron, therefore these two are equal. Now that was about the magnitude. How about the direction? So direction of the force experienced. Yeah, in the case of proton, it will be downward, attracted towards the negative plate and repelled from the positive plate, and in case of electron, it will be upwards. How about the acceleration? So we know that force is mass into acceleration, so that can be put as equal to Q into E, and which in turn gives the expression acceleration is equal to QE upon mass. So this will be equal to, in case of proton, it will be equal to QE divided by mass of proton, and for electron it will be QE divided by mass of electron. Now we know that the proton is heavier, 1837 times approximately, so this can be written as QE divided by 1837 times the mass of electron. Now therefore the acceleration experienced by the electron will be 1837 times higher than the acceleration experienced by the proton. And how about the velocity? So velocity will be equal to v equal to u plus at, and initial velocity is 0, so therefore v is equal to at. So for a given time, for a given particular time value, since acceleration, so I can put it like this, velocity of electron will be higher than the velocity of the proton. Why? Because the acceleration is higher. And let's say we have the time t. Time capital T is the time to reach to the plate. So in case of electron, the time to reach the plate will be smaller than the time taken by the proton to reach the plate. Yeah, because the velocity of electron is higher, and that's because the acceleration of electron is higher. So electron will reach to the plate faster than the proton. And where does it reach? Destination. So electron being the negative charge, it will reach the positive plate. Maybe I can call the plates as positive plate as A and negative plate as B. So electron will reach the positive plate A faster than the time it takes for the proton to reach the negative plate B. So these are essentially the differences in the nature of the motion of the proton and the electron.